Hello guys, welcome back. So here we have another question on communication systems from GATE EC 2022. Consider a channel over which either symbol XA or symbol XB is transmitted. Let the output of the channel Y be the input to a maximum likelihood detector at the receiver. The conditional probability density functions for Y given XA and XB are, so f of Y given XA of Y is e power minus Y plus 1 u of y plus 1, and f of y given xb is e power y minus 1 1 minus u of y minus 1, where u is the standard unit step function. The probability of symbol error for this system is dash. So to solve this question we need to know what is this maximum likelihood detector, right? So let us see that first. So you have your transmitter. So this is sending symbols XA and XB, right? At one time it will send XA, either XA or XB with certain probability. Let's not go into that probability because they haven't given anything. So now at the receiver side what we do? So this goes through a channel, right? So this channel will add noise and other things, whatever non-linearities, and then we have a receiver. So in the receiver side what they are saying is, if we transmit XA, whatever value y we are getting here will have a probability distribution given by this function. On the other hand, if we transmit xp, whatever y we are getting will have a probability density given by this function. So now let's say we are transmitting xa. Let's say xa is some minus 1 for example, and xb is plus 1. And if we assume that our distribution of y given xa is something like this, Gaussian, and y given xb is again Gaussian like this. In this case it is not Gaussian, it is some exponentially decaying function. So this I am giving as example. So now what we have to do, based on whatever, so the points we received can lie anywhere in this region. So based on whatever we received, we need to guess whether it is xa or xb. So one straightforward way of doing it is you take the center point. So minus 1 plus 1 is 0. So I will say that if I get a data less than 0, I will classify it as minus 1. If it is greater than 0, I will put it as plus 1. So that one possible way. This is because it is both are symmetric. Suppose this has a unsymmetry like this. So then depending on that, I will keep shifting my thresholds, right? So that is what usually is done. So now to detect this itself, they are giving we have different methods of detecting it. So one such method is this maximum likelihood detector. So now we'll go into that. Maximum likelihood detector. So this is also called as your ML detection. So in this what they are saying is, let's say transmitter side I am transmitting some XA, XB, XE, how many ever symbols possible. And at the receiver side I am receiving, let's say, some Y. Okay. So now what I will do is, I will see the conditional probability of Y given XA, Y given XB, Y given XE and so on. So I will compare all these and whichever is maximum. So max of P of Y given Xi. Then I will say that whichever is maximum Xi, I will classify that particular point as Xi being transmitted. So this is easy, right? So for this example, if you see, if let's say this is not there, I will take this. I will put here. Let's say for this example, it is something like this. So let's say our point falls here. So this is your conditional probability of P of Y given XA, and this is P of Y given XB. So if Y falls here, my P of XA is greater than P of XB. So then I'll say the transmitted symbol would have been XA. So the received symbol I'll classify it as XA. Now, by doing this, what is the probability of error I am making? Let's say I am close to this. Okay. So if something Y falls here and I classify it as XA, but there is also tiny probability that it can be XB, right? So up to this point, I'll be classifying it as XA, and here I'll be classifying it as XB. But even here, when classifying it as XA, I have this probability of XB being wrongly classified as XA. That is my error. So I need to find the area under this. Plus, when it is XA is transmitted and I am classifying it as XB, that is also an error. So that is nothing but this region. XA is transmitted, but I am classifying it as XB. So these two errors will give me the probability of error. So this is for the case of Gaussian distribution. Now they have already given some other distribution. So let us try to plot for this and try to find the probability of symbol error for this system. Okay. So same way only, and it is straightforward and easy. So only thing is we need to plot this correctly. So for y given XA, let us plot first. So what is u of y plus 1? It is unit function shifted to the left by 1. So it starts from minus 1. So this is of, and then we have e power minus of y plus 1. So at minus 1, what is this value? It is gonna be e power 0, which is 1. So this is something like this. And then it's decays, right? Decays like this. So this is my f of y given xa of y. Let me call this as y. Okay. So now let us plot this y of f of y given xb. So what is this? 1 minus u of y minus 1. Y minus 1 is nothing but it starts from plus 1 and goes to infinity. But 1 minus this is the inverse of it. So it is something like this, right? So if I take it, so it is something like this. And that into e power y minus 1. So e power y minus 1 in the negative direction, how it will fall? It is going to fall like this. And that plus 1, what is its value? It is again 1. So it is going to fall from here on. And if you notice at 0, both its values should be same because it is symmetric around 0, right? So this is my f of y given xb of y. So now we have this. Can we do our ML method here? So what will be the maximum likelihood? In this region, if you see, from minus 1 to minus infinity, if you see, you have only your xb. So if it comes here, we can directly say that it is just xb. Okay, xa is not overlapping. But from minus 1 to 0, if you see, your xa is greater. So what is the error you make on xb? This is your error. Error on xb. Similarly, once it crosses 0, then your xb is greater. So you will be taking this as your output, and for greater than plus 1, anyway it is only one symbol is there. So it is gonna be xa again. Again here, what is the error you make on xa? So this one is the error you make on xa. Again, you should be careful that you should not include this as your error. Why? Because here there is no overlap. Here only xb has a probability of occurring. So whatever symbol occurs, whatever output occurs here, we can close our eyes and say it is only gonna be xb. But here it is not the case. Here it can be either xa or xb, and depending on the likelihood, we are saying this has a higher probability of occurring. So we are okay to make an error because here your xb is having lower probability of occurring. So our probability of error is also going to be relatively lower. So now in all systems we cannot get rid of this error. We can only make it arbitrarily small. So only from -1 to 0 you are making an error on xb, and 0 to +1 you are making an error on xa. So now can we calculate the probability of error? So probability of error is, first you also need to give the probability of xa. The transmitter sending an xa, and then we are making an error on xa. That is the probability of error, right? So it is f of, this is this region, which is integral xa is 0 to +1, fy given xa of y into dy plus p of, we are sending xp and it is getting detected as xa, which is nothing but -1 to 0. This region, f of y given xb of y into dy. Again, if you notice, these both are going to be symmetric. So you can either directly put these two as equal and take this outside. So p of xa plus p of xb into whatever. You can evaluate just one of them. So f of y given xa, let's do it, into dy. So now if you notice, p of xa also they haven't given, p of xb also they haven't given. But we know that p of xa plus xb is equal to 1 because the transmitter is only sending two symbols, right? So their sum should be always equal to 1. So then your probability of error is nothing but integral 0 to +1 fy given xa of y into dy. Suppose they have given unsymmetric whatever the conditional probabilities, then the knowledge of xa and xb should also be necessary. So in that case they might ask what is the maximum error you can make that way, right? So then you will be choosing this xa and xb such that your error is maximum or something like that, okay? But for this question they are equal and we are equating it to 1. So now what is f of y given xa? E power minus of y plus 1 u of y plus 1. So 0 to +1 e power minus of y plus 1 u of y plus 1. Again u of y plus 1 is gonna be 1 in this entire region. So it is 0 to 1 e power minus of y plus 1 into dy, which is equal to e power minus of y plus 1 divided by -1 from 0 to 1. So this is nothing but e power minus 2 plus e power minus 1. So it is e power minus 1 plus minus e power minus 2. So this you can calculate using your calculator. And this comes out to be 0.2325. So they will be asking to round off to 2 decimal places. So it is just 0.23. Okay.